Okay, so what we're talking about here is quadratic form. And I put a problem on the board that is in the quadratic form. And again, we remind ourselves that the quadratic equation is right here. We're going to end up using that. That's ax squared plus bx plus c equals 0. And what I want you to catch here is that it's a power of 4, a power of 2, a power of nil. You know, it's like we're squaring each of these two, x to the 4th, x squared. That's a quadratic form. It could be x to the 6th, x3 in a number. It could be x to the 8th, x to the 4th, no number. So this is a quadratic form problem. But the thing is, I can't deal with it how it's currently set. I have to make it look prettier. And I picked a problem here. And maybe I'll change these numbers. We'll just pick something different. We'll start with negative 8 and plus 7. Then we'll do another problem with those numbers. All right, we'll do 2 of them. This one's the first one. What I would see first is I don't want to deal with this stuff. So I'm going to say, let's let u equal 4x squared minus 9. Let's let u equal the stuff inside, because this is going to make our problem a lot better. All right, so if I do that, I rewrite it, I get u to the 4th minus 8u squared plus 7 equals 0. I'm already liking that a lot better. But I want it to be in this format over here. Ax squared plus bx plus that. So I'm going to say let v equal u squared. Okay? Then I get v squared minus 8v plus 7 equals 0. Well, heck, I tell you what, I can do it with quadratic formula right now. Or what we should do with this one that I made on the fly is this one factors. All right, so we're going to do it both ways. One, I think this one factors. So on this one, if I go entire page, if I factor it, I get v minus 7 times v minus 1 equals 0. We quickly know by solving by factoring that either v is 7 or v is 1. That is not the answer. That is u squared. We know v is u squared. So we know u squared equals 7, or u squared equals 1. Okay? And again, one more step. Take the square root of both of these. I get u is equal to plus or minus the square root of 7. Or I get u is equal to plus or minus 1. I go all the way back. I didn't want u either. I wanted this. I want x. Well, u equals 4x squared minus 9. So I get 4x squared minus 9 equals plus or minus 7. And 4x squared minus 9 equals plus or minus 1. And I can solve both of these by moving 9 over and dividing by 4. All right? And this is a lot of work. 4x squared equals 9 plus or minus the square root of 7. Divided all by 4. All right? How do I get it? I take the square root of this, plus or minus, and there are going to be, 2 of your answers. The other one, again, going to maybe 75%, so I can do this. All right, maybe I'll clean this up a little bit. So again, both of these are 4x squared equals 9 plus or minus the square root of 7. 4x squared equals 9 plus or minus 1. Divide both by 4. And then they're squared, so you take the square roots. And we know the square root of 4 is 2. So we can write this as 9 plus or minus the square root of 7 over 2 plus or minus. That's one of them. Over here, it's plus or minus the square root of 9 plus or minus 1. 10 or 8, you can figure that out yourself. But there's the 4 answers. And that's just a ton of work. And it worked out by the numbers I picked. This one's solved by factoring. If it doesn't solve by factoring, if I go all the way back up to here, after I did all my substitutions, I can solve for v the same way. I can use the quadratic formula and say, hey, a is 1, b is negative 8, c is 7. And I can use this thing. And I can get v equals 8 plus or minus the square root of 64 minus 28, right? 4ac. I'm doing the math really fast over 2a, which is 1. All right? And I get v equals 4 plus or minus, well, that's the square root of 36 over 2. So I get b equals 4 plus or minus 3, which is 7 or 1. All right, which is what we had here for b. And then it becomes the same exercise. We figured out b. Now we have to go back and figure out u squared and then figure out x. I'm going to do another one. We'll see if this one factors. This one, let's do another. Again, we like problems where the inside is something that can be factored. All right. Quadratic form, so this is to the 4th power. This is going to factor, guys. All right, this is going to factor. We're doing this as a factor problem. I'm going to let u equal 9x squared minus 4. Let's substitute for that, then I get u to the 4th minus 10 u squared plus 9 equals 0. This factors right now. You can either put the b in to see it, or I'm going to do it right now. U squared times u squared equals 0. There's our u to the 4th. Right here. Now, I have 9. To make 10, 9 is 1 and 9. So how about minus 9 minus 1? All right. And now I can solve these both factors. This is u plus 3, u minus 3. The second one is u plus 1, u minus 1. I could have done this in the first example. This is just another method. So now we know the 4 solutions. The 4 solutions are plus or minus 3 and plus or minus 1. But that's not what it asks for. It asks for x, but we know u is equal to this. So I have 4 equations set up. I have 9x squared minus 4 equals 3. 9x squared minus 4 equals negative 3. 9x squared minus 4 equals 1. And 9x squared minus 4 equals negative 1. A, B, C, D. 4 equations to solve. Again, move the 4 over. I get x squared equals 7/9 for A. I get x squared equals 1/9 for B. I get x squared equals 5/9 for C. And I get x squared equals 3/9. So when I take the square roots of these 4, these are all x squared, again, A, B, C, and D, you get x equals plus or minus the square root of 7 over 3. I get x equals plus or minus 1/3. I get x equals plus or minus the square root of 5 over 3. And I get x equals plus or minus the square root of 3 over 3. And with that, I have found 8 solutions, which would make sense because if we think about this problem at the very beginning, 4 and 2 make 8. My 8 solutions to this equation are right there. Again, if it doesn't factor, we can plug it in the quadratic formula. Otherwise, we can factor as we go, looking for the forms, quadratic forms. Keep practicing, tough problem, keep working at it.